Hey everybody, thanks and welcome for another exciting Atlanta.net Users Group meeting. We're a couple minutes later than we normally would get started, so I'm just going to ask that if you're not speaking, please make sure you have your mic muted. And once we get things kicked off, if you could turn off your camera, just so that it's less of a distraction for people that are watching Jason's presentation here. And with that, I'm just going to turn things over to our speaker tonight, Jason Bock, and we'll get things kicked off. Jason,
all right.
you.
Let me do the share of screen.
And I'll keep an eye on the chat, and if there's any pressing questions that come up, then I'll bring those up.
Okay, yeah, because unfortunately I don't have, as odd as like my work setup over here, I have lots of monitors. My personal one doesn't. I have to get one of those at some point in the future. So I can't have the chat off to the side and looking at it. But if, to that point, which is something I was going to say anyway, but if you do have questions or comments or whatever the case may be, don't feel bad. Even if you got a mic and you just want to interrupt and say, hey, Jason, get my attention. I will probably be a lot into code demos in Visual Studio. So to me, it's the equivalent of just being in the room and raising your hand, and once I see it, I'll answer it. I'd much rather have an interactive conversation than me just going through a bunch of examples and not knowing if people are are getting it, or if something's confusing, I want to clear it up. So please if you want to put in the chat, that's fine too. I'll check that occasionally. But if you just want to break off a mute and ask a question, be happy to answer that. So with that in mind, again, my name is Jason Bock. I'm a developer advocate at Quicken Loans, and my talk tonight is what's new in C# 9. So that's a little bit of information about myself. If a question comes up later, just send me an email at jason.r.bock@outlook.com, and I can answer it offline as well. If you want to get the code samples of what I'm going to show in my demos, that's the first link there. The second link is a specific demo on source generators. That's not part of that one, so that's where that code is coming from. And if you want to get the slides, I have slides that I've done for my presentations at that third link. So just go there and you'll see the what's new in C# 9 talk, and you can download the slides. And you may want to do that because as I go through the slides, I sometimes have URLs at the lower right that are related to what you're seeing on the screen, so you can dive deeper and look into that. And also on the last slide in the notes section, I also have references to other things that you can look at later on if you'd like. So I'm going to spend a little bit of time on the evolution of the language and how we are where we are right now with C# 9. Most of the talk is going to be doing demos and showing how these new features work. And then we'll spend a little bit of time at the end talking about future directions and where C# may be headed. All right, so C#, I'm guessing if I was in the room right now, we were in a physical room, and I'd ask how many people have or are programming in C# right now, I would venture to guess that it'd be a safe bet that everybody would raise their hand, or virtually everybody would. Okay. Now, maybe you're new to the language. Maybe you've been doing it for 5 years. Maybe you're an unfortunate soul like me that's been doing it even before it became 1.0. If you remember way back in the day, there was next generation web services and Com++, I think it might have been called at one time. There was Cool was another thing it was called. There's all these code words and acronyms, and then they finally landed on .NET with C# being this new language, which was really, historically this response from Microsoft because they got slapped on the hand legally about tried to combine Sun and Java. about Java and their extension of the language, so to speak. So they ended up building C#, and the first release was in 2002. Well, now we're in 2021. It's nearly 20 years old as a language. And as you can imagine, with a language that's popular, lots of people programming the language, and it has that long of a history, there's been a fair amount of change. And I'm not going to go through all these features. I'm just going to kind of just, peruse these real quickly, just kind of go through one over the other as I'm talking. But just to give you a feel, if you haven't started in the language way back when it first came out, this is the evolution of all the features and how they got into the language. It's weird to think of a version of C# that didn't have generics. That didn't come until version 2. So if you are a unfortunate person that still has to support a project that's in C#1, I feel honestly very, very sorry for you, and I feel for you. That's just not a fun place to be. So if somebody asked me what was the most impactful feature in C#, I'd have to make a strong argument for generics. I could not imagine. I mean, there's other ones that are good, but I couldn't imagine trying to program in a language without generics. It allows so much expressivity in what you're doing. Version 3 added a whole bunch of features that basically supported LINQ, and it also kind of taught us an interesting lesson about features and when you had keywords and stuff, because I'm personally a var person. I love var. I actually set up my editor config to enforce me using var rather than type names. But var wasn't a keyword in C# until much later. So I just want to, do I want to put it in here? Yeah, let's do that. So we're going to get into this code example eventually, but you can do this. Now you're noticing above, there's all of a sudden a whole bunch of red squiggles under my code. That's because var is a valid class definition. So you could have done that before C#3. Of course, if you do this, that now makes the usage of var here everywhere a literal type and not type inference. So everything suddenly breaks. So don't do this. It's just, again, one of those things of if you include a keyword that hasn't been there before, you can sometimes end up with code that's quite interesting. Do that on April 1st and maybe drive somebody nuts on your team. So that's what was added in version 3. Version 4, not much. There's a couple features like dynamic, which I really try to avoid for many, many reasons. But, the feature set got a little smaller, and then in version 5, async and await, which is a big feature in and of itself, was added, but that was kind of it. And part of it, I argue that the reason why there was kind of less and less churn on the language was because while this was all going on, there was this thing called Roslyn that was being built. I've heard that Roslyn almost started as soon as the first version of .NET came out, that somebody ported the C++ based compiler to C# as an internal project. And that was basically their intent, is to eventually make that the basis for their compilation. It just took them, about 13 years to get there. So this project was something they had announced and were working on and giving little snippets of that. If you remember PDC, Anders Hallsberg would talk about the compiler as a service. Well, long story short, Project Roslyn ended up becoming the compiler API. When you compile your code in C#, you're actually using something that was built in C# to compile your code. And this API is open. You can use it for whatever purposes you want, benign or nefarious, it's up to you. But the cool thing about this is that everything with the language, the compiler, and pretty much at this point, everything in .NET is open source. It's all on GitHub. It's all available for people to peruse and browse and look at. And it's a much different world than where we were with a lot of stuff in Microsoft from, 10-ish years ago. Now, to be fair, most, if not all, the people that do a significant amount of contributions to the language, like you can see here, those names are people that actually work at Microsoft. Cyrus did leave for a while, but then he's back now and he's doing the same stuff he was doing before. That's not to be surprised, not to be surprising. Most of us are not going to spend 40 hours a week working on language design and fixing bugs and things like that. But if you do look at this list, there are people that have made a lot of contributions, of varying size to .NET and or C#. And that's really cool to see that the community can be an intricate part of performance improvements and language improvements and things like that. So if you are interested in starting to become a part of this and actually do contributions, again, if you go to the link on the lower right and in filters, if you want to look for, for issues that have been marked as community, those are the ones you probably want to pick from, because those have already been curated to be designated as, this isn't going to be that big of a feature or this big of a fix. So it's not going to completely overwhelm somebody and leave them frustrated because it's going to take a fairly long time. And plus the team may just go, we don't have a ton of time to spend on this, but if somebody in the community wants to help, they're more than welcome to try and give it a go and see what they can do. Okay, so that's for the people out there that really want to contribute and be part of the team. Now from 6.0 on, everything was based on this new compiler API. And one of the interesting and I think good consequences of this is that you're seeing a lot of features being added in each version of the language. And the size and scope of the features is, you can argue if they're big or small. I would say they're generally smallish, but there's a lot more of them. And they've also been able to get a lot of feedback from people and determine whether a feature should be in there or not. I know with version 6, they actually pulled a feature right before they actually said, this is what's RTM. And that's okay. That was all done in the open. It wasn't, something that was nefarious. They just said this feature is not completely baked and we have to remove it and maybe add it at a point in the future. Okay.
Hey, Jason, could you minimize that little Teams block there that's hiding part of your URL?
Yes. Yeah, that would help. I didn't know if that would actually show up in the, since I'm sharing my screen, yeah, that would show up. So thank you for the correction. So see, I'll take that. I'll take, somebody says, hey, could you do this? I will do that. So, so with version 6, that's where a lot of change starts rapidly occurring in the language. And whoops, the other way. 7, this was the first and to this point only language version that actually had point releases. So not only did they have a 7, but they toyed with this idea of, well, we'll have 7.1, 7.2, and also 7.3. They did not do this, though, in 8. So there was no 8.1. As far as I know, it was just version 8. Okay. Now, one of the interesting things about version 8 is with, it's default interface methods here. It's really default interface members. Is that feature required a change to the CLR? And that's where you start to see this bifurcation of where you could run the language. So this is a picture that somebody created, and I got the link there from Twitter. And basically what this is trying to show is .NET Framework is done. It's frozen. It's sunsetted. Use whatever term you want to use. But that Windows-only version is not going beyond 4.8. That's where it's going to stay. All the change and features and everything else is basically now what we call .NET 5, which is soon to be .NET 6 later this year. Yeah. So because it's now essentially just any security patches, any bug fixes, but that's all that they're going to do. You don't get default interface members if you're targeting .NET Framework 4.8. Some of the other features, people have figured out how you can kind of work them in, but it's arguably a little kludgy. But this is just going to continue from C#9 and C#10. The only way you're going to get more of these features to work right out of the box and not have to try to screw with how do I get this to actually, work and make everything work on .NET Framework. Just be on .NET 5 and beyond. That's really where you're going to need to be. Okay. So with version 9 that got released with .NET 5. And we have a whole bunch of features here that I'm going to go through. Some of these I'm going to go through really, really fast because they're pretty small and have a very focused audience in terms of the problem they're trying to fix with that feature. But keep in mind that features in C# are not added lightly. There's a lot of debate, a lot of discussion. It's interesting to see somebody propose a feature and get a lot of feedback on it and get kind of defensive, like I'm sure this feature would be used by millions of C# developers, and they don't have that understanding of all of the effort, all of the work, not just in building it, but in maintaining that over time. It's going to be there. It's not going. They're just not going to pull a feature. So there's a lot of thought that goes into these. So even if it's a feature that you go, yeah, I never see myself using this. It seems kind of worthless to me. That's a fair statement, but it's been requested by somebody somewhere, and the team has determined that it has value being in the language. Okay. So again, some of these I'll spend more time on than not. Without further ado, let's get into that. Now, when I show you the code in the example, you're going to see a feature right out of the bat. When I've done this talk before in the past, I have just a program console application, and I just comment and uncomment methods that I want to show, and then we dive into each feature based on what's in that method. I'm doing the same thing here, but when you look at it, it may look a little weird compared to how you've done program files in the past. And this is called top-level statements. So if I go into this code here, and let's scroll all the way up to the top, you may look at this and go, where's the program file? Or the program file is here. The program class, where's the main method? What's going on here? You can now declare one file in your project and only one file that does this. What do I mean by does this? Well, you see we have some using statements at the top, and then I get right into comments and a function call and all that stuff. If the compiler picks up that you don't have the next thing being like a class definition or struct or whatever, and you're starting to just have statements and method calls and whatnot, it's going to go, oh, this is your one and only top level file. And so what we're going to do is synthesize a program class and a main method for you, and that's what we're going to compile in and run. Okay, and in fact, when I show records, which is the next feature, I'm going to dive into a tool called ILSpy to kind of show you what's being generated when you do records, but then I'll also show you what's being generated for the program and main method as well. Just for the curious, you can actually see then what's going on. I have to admit, the first time I saw this feature, I kind of went, why? Why are you doing this? This doesn't seem like a big thing. Well, one of the things that you may have seen in C# 8, or maybe it was 7.1. I have a PowerPoint with all of them. I could go look. But there was, in one of the recent versions, where you could say using var database is equal to new database, that implements idisposable, and you always had to have a block there. You can now just have that as a line that ends with a semicolon, and then everything underneath it is in the scope of that disposable object. Okay. So these little things here and there that if you don't want to write as much code, that's what they're trying to get more and more to. You can literally, if you want to write now, this isn't going to show up correctly because I'm going above everything here. But if I wanted to and do the canonical hello world, I can do that in one line of code now. Okay. And so for people that are new to the language as well, this has a lower barrier of entry. I don't have to think about, why do I have a using? Why do I need this program class? Why do I need a main method? A lot of other languages have this capability just because that's how they're designed, that's how they're built. You can now do this in C#. But this also, I think, works rather nicely for applications that you're building. If you think about building an ASP.NET app, you have the program file, and you have all this kind of cruft there where you really don't need it. You could basically have just one line that says start it up and off it goes. Okay, so this is like a lot of features in C# recently where I see it at first and I go, I don't really get the benefit of this, but then I started using it and I start going, yeah, I kind of like this. In fact, now I create all my program files. I wish Visual Studio would actually have a template out of the box. And maybe it does and I missed it, but where you can generate a project with a program file actually has like nothing in it, and you can just start building code this way. Okay. So again, you're not required to do this. This doesn't mean you have to change all your program files, but if you do want to write code this way, you can. And by the way, you may see in my code that I have links that are going to be related to each feature. So when I go to the methods, you'll see there's a link above like the previous line. And so when you get the repository, you can just click to where this is all documented in docs.microsoft.com and get more information on them that way. Okay, so that is top level statements. Let's go into records. Records has, as a feature, received, I think, the most press, the most visibility from people that are talking about C#9. And this is a feature like source generators, which I'm going to save the best for last because I think source generators are absolutely awesome, and people should at least be aware of what they can do because they give you a lot of power. But these features actually went through a lot of churn, a lot of prototypes, a lot of discussion as to how do we actually define a record. Okay, and I may even be saying, what's a record? I'll dive into the details in just a moment. You can think of a record as a really succinct way to build what are typically called POCOs, okay, which are plain old CLR objects, basically a class with a bunch of properties. That's it, okay. It is that, but there's actually more that you get, but you still have a very succinct syntax, okay? So if I have this code here to demonstrate records, I create a new customer, I print it out, which we'll call toString here, or I could print it out this way by getting the age and the name. Now notice I have this comment here that says this won't work. It's because the way that properties are defined by default in records, they're read-only, they're immutable. So you can't change them with this syntax. In fact, if I comment this line of code out, you'll see I'm going to get a squiggle and it's going to tell me, yeah, I can't do that. Okay? I can deconstruct the customer into its age and name values, print those out. I can use this thing called withers. This is kind of a new syntax where I can say, I have this thing and I want to make a new thing from it because it's immutable, but I want to just change the name. So originally that customer had Jane, it's still going to have Jane, but my new customer is going to have the age is 22 and the name is Joe. Okay. I can also define mutable records if I want to. You'll see how in a second. Okay. And we're going to go into ILSpy in a moment to see just how this is actually created. How are these things done? Because if I create a second customer down here, it just so happens to have the same values from a property perspective as this customer, this is going to be true. In fact, if I run this and I get the resultant console window to come up, we'll see once that actually shows, there you go, that equality is true. Yeah, but as you see now, when I go to the customer definition, it's one line. There's no toString, there's no equality on what I did, there's nothing, okay? So there's this new keyword, record, that allows you to define a class. And that's what records are right now in C#9. They can't be structs. They are classes by default. They're not sealed, so you can inherit from them. But you can basically define a record like this and use this kind of constructor-like syntax, which what it will do is create two properties, age and name, for you. They just are synthesized out of nowhere, which is cool, okay? That's why when I did this, that's why that worked. That's why I got the age and name properties. But what about the equality and the deconstruction? So if I go into, you don't know what ILSpy is, it's a decompiler. It's been around for many, many years. It's awesome. There are other ones out there as well, but I like this one. So if I go look at, and let me know, Ken, if this completely screws up the recording. Sometimes, moving in gets a little wonky when you're sharing a screen. Hopefully it doesn't.
Yeah, you should be fine.
Okay, good. Awesome. Okay, so you'll notice here, though, in my assembly that I have this program class that has this kind of odd name to it with the main method. That's what that top level syntax thing is doing. That's what it's synthesizing. And then when I dive into what the method's actually doing, you'll see that it calls the method there, and then it actually has within the main method itself a private method called demonstrate records. Again, this is just all compiler magic that it's doing underneath the scenes for you that gives you the same semantics and execution that would happen if you would have done that explicitly. Okay. Well, let's go to the customer record. As you can see, it's just a class, but it has the properties here. It has a constructor here. It overrides toString for us. So you'll notice it uses a string builder, and it basically gets the properties and their values for us. We don't have to do that ourselves. That's done through this print members method. It will also implement equals and not equals for you, get hash code. It can do cloning. It can also, if I go down here, there's the deconstruct method. Again, all of this is built out of the box for you with records. Now, because all of this is done for you, and there's some tricky semantics with the class itself and can I inherit from it. Right now in C#9, you can only inherit records from other records. So if I come back here, you'll notice I have an identified customer that adds in an ID that derives from customer here. Same thing with a valued customer that has money. But I can't create a class that would derive from customer. That's not allowed. Okay. I can also specify things out of the box. Well, the things that are done out of the box for you, I can also specify things if I want to. So if I want to create methods in there, I can do that. If I want to create my constructors, I can do that. If I want to create my own properties, I can do that. So you'll notice that I can create a name that would be mutable by having get and set. But the way the properties are done with records, they're actually using a third option, which is called a init. Okay, so what you can do now is have a property that is settable with init. And what that means is you can set that property value either within a constructor or in the context of an object initializer. Okay, so I could, if I come back here, I could say instead of var second customer, I could do second customer like this and say new customer. Okay, and then have the age equal to 22 and the name equal to Jane, like that. Okay, and that's perfectly fine. Okay, it should be. Oh, that's because, yes, that's because I'm using the syntax here that forces me to call the constructor. But if I have a mutable constructor, customer, then that will work just fine. Okay, so that's where inits are allowed to be set within the context of an object initializer. Okay, and this is also why the equals works here, because the equals that's generated does it by the values in the properties of that object. It essentially looks at the data and does that comparison, which for most cases is probably how you want equality to be defined. But you don't have, like again, if I go into ILSpy here and I go look at equals and how it's defined, I don't have to write this code myself anymore. Records do that for me. So I jokingly said, I don't know, about a month or two ago, that everybody should start defining all their types in C# as records, because I don't have to generate all that code myself. I was being facetious because there's probably reasons why you don't want to do that in cases. You don't want all the overhead of all that code being within that class. That's up to you. That's kind of debatable. But for a lot of things that you want with your object definitions via how you define it in the class, records will probably do what you're looking for. So this is why I think this feature is getting a lot of visibility, because it can get rid of a lot of boilerplate code that you write in cases where you're building DTOs or POCOs, and just do them through records. If I go back to the record here, I could have a POCO or a DTO literally defined in one line of code if I wanted. Yeah. So that's records. Okay. go to target type new. I mentioned that I like var. I think var is a really cool thing. Some people still insist on saying that I want customer is equal to new customer because I want to be really, really verbose and say the type name twice. I don't like that. I like var. There are some cases where you can't use var though. If you're declaring a field, you still have to give the type definition for the field. Okay. Well, in C#9, there are cases now where you don't have to do that. If you don't specify a type, like what I'm doing here, notice that the new doesn't say customer, it just says new. It's because I've said the customer variable is of a customer type. So you obviously want to call the constructor on customer that takes an int and a string. Okay. Again, this may look a little weird at first. And if you use var, you can't do this because var is assuming the thing on the right is what var is going to do type inference on. So if you have nothing to infer a type, it don't work. Okay. In fact, if I be really literal and just do that, it's going to bark at me. It's going to be like, I don't know what you're doing. Okay. So where could this be beneficial for using this? Well, the one example I gave where I'm declaring a field, I think is one of them. Okay, so if I go into this wrap dictionary where I'm basically wrapping a dictionary, notice that in the declaration of the field, I don't have to say new dictionary of int and string. I can just say new right there. So a little bit of code saved. The other place is if you have to pass in a value to a method invocation, specifically one of the parameters. Okay, so one of the arguments you're giving to the parameters is a new customer. You can say right at the call site new and call the constructor and new up a customer right there. Okay, so that's another place that I've been using it. There's debate that this makes it less readable, and some people have barked strongly at this syntax and they don't like it. But you know, it's something that I think in certain cases actually help and make things, I think, a little easier in some ways to read. So it's kind of, you know, what you like and what you don't like. Nobody's forcing people to use var, so you don't have to do this if you don't want to, but it's now available. Okay, so that's target type new. Module initializer. This one I'm actually going to run. Okay, so let's go down here. Let's actually go into that code right away. Actually, not that code. We want to go into initialize data because I want to make sure that's commented out. Correct. Yay. Okay. So I'm going to print out that I'm using this, and then I'm going to call initialize data value sum. Well, if I run this, what you'll see is once it runs, I should be getting an error, and I do. And the reason why is because that property is not set. There's no data in it. Okay. So what I could do in initialize data here is create something that's called static constructors, type initializers. They're a way for you to say the first time anything is referenced on this class, I want this method to run, and then I want some initialization to be done. That can be done, but there's a way that you can do this that's module wide. And modules are this holdover from the early days of .NET where you could have assemblies that were multi-module. That just nobody does that anymore. Compiler doesn't build things that way anymore. Nobody does that. So just forget what I said. But that artifact is still in there, where an assembly contains one module, your module contains your types, and so on. In fact, I think if you go back to ILSpy, you'll see that there's this module in here, internal class module. Okay. So the point is that the module is basically the container of everything within your assembly. And there's always been a way in .NET to say, I want this code to run before anything else is run. Doesn't matter what type it's in. I want this to run first, even before the thing in program.main runs. Okay, so that's what this module initializer attribute is. So if you put this on a method, and there are some restrictions, the method that you put this on, has to be returning void. It has to be static. It can't be generic, and it can't take any arguments. Okay? And you can only have one of these within your whole module. If you try putting more than one in there, it's going to say no. It's because it won't know which one do you want to run before the other. But if you put one of these in, then this will get run before even this gets invoked. Okay. And just to prove that, let me run that and show you that now initialize is called and this is called, and then that code doesn't fail. We actually get the sum of the values in that array. Yeah. So this is one of those smallish features that I don't see a ton of people using. You definitely don't want to put these in all of your libraries or what are your DLLs. You want to only have this in something like an executable, because if I put this in my project, my assembly, my NuGet package, whatever you want to call it, and then other people do that and all those things are put together in one project, it's going to go, I don't know which one to call. I don't know which one to do. So you don't want to do this in places other than in your executable host. Okay. But now you can have something that you know will fire before anything else runs in your code. All right, local flags. This is one of those small features, and it's an interesting one though, in that if you've ever done things where you are doing stack allocs or you're doing unsafe memory management, which is possible in C#. I've never done that. I can't even tell you the last time I actually used explicit pointer syntax in C#. I don't even know if I've ever done that. Okay, so maybe you have. Maybe you've had to do that for p invokes or something like that, but it's not a very common thing. Okay. But what's interesting about the way that C# allocates your variables is that by default, your variables are 0 init. What that means is that basically all your variables have a default value of just zeros. Okay. There's a slight, and I mean like slight overhead in doing this, something that you probably in most of your applications will never even notice. But if you are doing things with explicit memory management, stack allocation, you may not want to do that. You may want to skip that and say, I know when I'm going to allocate this and I know I'm going to actually use it, so don't take that extra step of zeroing it out first. Okay? So that's what this skip local init attribute does. Now, if I run this code, which notice pointer to the address of what GUID is, which is not something you're going to write typically. If I run this, you'll see that we should get a whole bunch of zeros for the GUID because it's going to zero it out. But now if I put this up here and I run this, you notice I got garbage in there. Okay. That's what that 0 init does. So should you put this attribute in all your code? No. Notice that this is only usable in unsafe contexts. It only is going to have any impact if you're actually doing explicit memory management, stack allocation, things like that. In my slide deck, in that last slide in the notes section, somebody wrote an article that does a great job of showing performance in applications where you're using skip locals init. And he basically shows, unless you're doing these things in your code, don't even bother putting it in there. You're not going to see any performance increases at all. Yeah. But if you are in that case, then you can do this and you might get a little bit extra performance out of your application. Yeah. Or number types, let's go to covariant return types. This is just kind of an interesting one. In C#4, covariants and contravariants were added into the language with interfaces and delegates. Essentially, it made the type system a little bit more descriptive in terms of what you and flexibility. Allowed more cases of things that you could return from members or take in as arguments to methods. The long and short of it is, it just makes code work the way I think most people's brains would work with types in C#. Well, there's still a case where you ran into, gosh, I wish I could do this. I wish if I was doing some type of Fluent API that I could actually change the return type. Okay, you weren't able to do what I'm about to show you until C# 9. Okay, so let's say you have some pipeline process that you add an identifier and then you add a name, and if you look at what's being returned from these, they're all custom pipelines. So again, it's that Fluent interface idea that you've probably seen in either your building, stuff like that, or you've seen those from NuGet packages. It's not an uncommon technique to build these APIs that way. Okay, so yay, that's great, but what's actually going on underneath the scenes? If I go to my custom pipeline here, you'll notice it derives from pipeline. Okay, but it also, on add identifier, it overrides the method and it returns custom pipeline. Okay, no big deal here until you look at the base type right up here. If you look at if you look at add name here, okay, you'll notice and add identifier that this is returning a pipeline and it's virtual. What I can do down here is I can override it and say I'm actually returning something that derives from pipeline. Before C# 9, you couldn't do this, and so you would have had to know that that derived type was actually going to return a custom pipeline, and then you'd have to do a cast so that the Fluent interface would keep moving down the line. And it was a little not pleasant. Now you can do this out of the box, and you don't even have to use generics to do it anymore. Okay, so small feature, but adds a little bit more expressivity and flexibility in the type system. Okay. These things that I'm going to go kind of through, I'm not even going to run it, but I'm just going to show you these because they're small, but you may find them useful. One of them is static anonymous methods. We've had anonymous methods for a very, very, very long time. If I'm looking for any value within this array, I can pass in this anonymous method here to do that. That's great. But notice that I'm capturing the value that's outside. Okay, this is what a closure is. Sometimes this can be a little confusing depending upon when the method's actually run, what the value of values is, when the value is captured. It sometimes led to a little bit of confusion. Okay? What you can do now is what you see in the commented code, which is like put the keyword static in front of the anonymous method definition. And this is why I have it commented, because it'll say you can't do this because I cannot capture the value here. Okay. You'll see I get a bunch of red squiggles, and it will say static anonymous function can contain a reference to value. So if you want to make sure that you're not doing any closing over variables or anything else, just put static in front of that anonymous method definition and you will be fine. Yeah. Local functions was a thing that was added in C# 7. They're kind of useful. I like them. Didn't like them at first, but I found that I use them a lot now. And you haven't been able to put attributes on a local method until C# 9. So if you wanted to, what you could do is I could put obsolete on this local function, and now I'm going to get an error telling me that it's deprecated. Okay, so for obsolete, that may be a weird case because you're like, I'm in that method. I should be able to figure out how to refactor it so it's no longer obsolete, because you can't call a local function from anywhere else other than within that function. But if you wanted to put attributes just for other things on that local function, you can do that now. So that's totally open to you. Okay. I'm going to skip discards and lambdas. Function pointers I'm just going to mention because they're there now. I have looked at function pointers, which you're sitting there going, oh, this is unsafe. And oh, I got the address of this same function here. What is going on? It's just a static void taking a value and printing it out. Okay. But notice what the invoke function is doing here. It's taking a delegate, that's what an action is, as the first parameter, but then it's doing this delegate star int void f thing here. Okay, this is a function pointer. For most code that you will write, you don't need function pointers, probably. If you are doing things with p invokes, or if you're really, really looking to squeeze out just that extra bit of performance, maybe doing things through a function pointer, which what the syntax is saying is the function takes an int and it returns a void, okay? Which is what an action is. It takes an int, and by definition, actions don't return anything, so it returns a void. Okay? That's just the syntax they landed on to do function pointers. So you can do this, but notice again, you have to be in unsafe context to do this and make it work. You get a little bit of performance, but you sacrifice some safety. So I personally am not going through all my code and changing all the actions and funcs to function pointers, because there's really no good reason to do it unless you are in a very high performance scenario and you do your performance testing, and you will see that there's a difference. Otherwise, don't do it. When you talk about partial method signatures, for a long time, the partial type or the partial keyword was in C# 1.0 all the way back from that day. I personally wouldn't use partial, not because I didn't like it, but because it never came up in a situation that I needed it to happen. That may be different for you, but for me, it just never came up. It wasn't something I needed. And what partial types are a way for you to say, this type can also be defined in other places in my project. Once that project is compiled, then all those partial definitions get munged into one type definition with all the different definitions in there, and that's it, okay? So this was kind of useful if you were doing things with, you had to work with generators, like when WinForms would generate a bunch of things underneath the scenes. But most of the time I didn't care. With the advent of source generators, where you may want to use partial things a lot, they've now made the partial keyword a little bit more powerful. So if I go here to partial methods, and you'll notice I'm getting two definitions down here because there are actually two partial class types for partial methods, okay? This is the way that you could define a partial method before. It had to be void, that was it, you couldn't take any arguments, blah, blah, blah. That's changed now. You can have different accessibility, you can return values from them, and this is definitely helpful because there's a lot more scenarios now that you'll probably want to use partial, especially if you're doing source generators, so that there's a partial definition somewhere and your source generator will add in a whole bunch of stuff for you, and then it just all works and it all gets put together. But I don't have to be limited by just a method that just takes void and that's it. Okay, so a little bit more options now with partial numbers. Pattern matching is something that's been added in C# since 7.0. And basically, I like to call it as they hijacked the switch keyword and made it so you can be a lot more expressive with what you're doing in a switch statement. It looks very different from the way we've always done it before, but you can still do it that way. But if you want, you can use pattern matching now in C# and get some rather succinct code. And I'm not going to go through all the options that have been there before, but there's a couple things that you can do now in C# 9 that I think are even cooler. Okay? So you'll notice here that I have this method that's going to qualify different values. Quirkle is a board game that I play a lot with my wife, and if you're interested in board games, look it up. It's simple, but it's kind of fun to play. And depending upon the score that you get, a higher score is better. But I want to say, give it an int, and then give me something that will qualify it. Oops, we don't want that. We want that based on the score. Okay, like 70 is the highest one you can get. -2 is impossible, so is 100. Well, how is it doing this qualification? If I go into here, you'll see here's the enumeration, and here's the qualification. I switch on the score, but now notice that I have these ranges here that are separated by the literal word and. There's also or, okay? Now the reason why they didn't do this, which was asked to the C# team, why didn't you just use and? The little bit hand-wavy answer, but it is actually correct, is that there are some cases with your Boolean conditions on the left-hand side of the arrow that if you had to use the and syntax, they wouldn't have been able to determine which and you were actually meaning to be where. Okay, They give an example somewhere, which I don't have memorized off the top of my head. But they basically said, well, if we want this to work, we can't use and or pipe or. We have to use literal and literal or. But now those are here for pattern matching. So you can see if I am within this range, that's the qualification I get. Same here, I could just be 12. Anything else is impossible. That's the default case. So you can do this now with pattern matching and being able to do these kind of conditional and ors in your pattern match. You can also do this, which I think looks really kind of small at first, but I like that this is finally in C#. Most people, if you've ever compared to null, you've done not equals to. And if you're wondering why I'm getting this kind of slash with the equals, it's because I'm using Cascadia code as my font. And so it puts this ligature in here that instead of it being not equal, it just makes it look like more of the math not equal symbol. Yeah? The same thing. That's what you're seeing there. Most people do it this way, works all the time. Unless somebody is being a jerk and decides to override the non-equals operator on that type so that the semantics of this won't actually be what you expect them to be. Now, again, that is not what people are going to do, but it could. The point is that the not equals operator or the equals operator isn't comparing to a literal null. That's what you want. You want it to be like, is this literally null or not? In C#8 with pattern matching, you could do this kind of weird property, empty property pattern match, which would only work if the thing you're matching against was not null. But that looks a little strange with those two empty set kind of brace look there. In C#9, you can do this now. You can say nullability is not null. And to me, I'm changing all my code now to do it this way because it reads, it's very clear, it's not just very unambiguous, it's completely unambiguous. This will work all the time. Either it's null or it's not. Okay. So, small thing, but I like that they added this in here. The last thing I'm going to talk about before we get to source generators is get enumerator extension, which is I can have my value customer, which if you remember way back when we talked about records, it had 3 properties on them. Well, if I go up here and make this my method that I'm going to run, okay, run it, because you notice that wasn't a for each loop there. And in that for each loop, when I for each over that object, which was just a record, I'm getting Jane 18 and the decimal amount. Why is that? Well, if I go to the definition of value customer, there's no get enumerator. But if I go into my project here and see enumeration extensions, I can extend value customer with get enumerator. And the compiler is smart enough now to go, oh, that should be used in for each. So even though the type definition doesn't have it, you can create an extension method that will work now in that for each scenario. Okay? And there are things like this all over the place in C#. More and more you'll see cases like the deconstruct method that I showed before. If you write a method like I did, well, I didn't. The compiler did it for me with deconstruct down here. But if you write that method where all the things are out and the method's actually called deconstruct and it doesn't return anything, the compiler will go, aha, I can assign a tuple to all the things that are coming out of that method. And that's just what the compiler does. But it's looking for a method of this distinct shape, if you want to think of it that way. Okay. Same thing here. If this doesn't have get enumerator on it, but you called that, it will say, well, then I'm going to look for an extension. And in this case, I have one. So that's why in this case, I can do a for each on that object. Okay. I'm just going to quickly dive over here and just take a look here. Oh, there's a lot of questions. You know what? Let me go through source generators, and then I'll kind of go back to these questions, and we'll hit those as I go through them.
Lots of comments, a few questions, but mostly.
Okay, so a lot of people giving their opinions on stuff, huh? Is that what I'm seeing here?
Yes, there are some questions though too, but
okay,
mostly opinion.
We'll get to the questions then, and I'll ignore the opinions. All right. So source generators. This, in fact, when I proposed talks to Ken, I said I could do a whole talk on source generators because I find it so cool. He said, come back to reality, Jason. Let's just do a talk on C#9. Maybe he didn't say it that way, but that's kind of the feeling I got. And I kind of understand why. Source generators is not an easy feature to use and implement and make it work. And you'll see what I mean by that in a moment. But the power, the extensibility that you have with source generators it's amazing. It's amazing to see all the things that people are building with source generators. And let me just go through an example here to kind of give you an idea as to what you can do with source generators. Okay. So what I've got here is a package that I have called inline mapping. And it's kind of like a poor person's version of AutoMapper. I'm sure everybody here has at least heard of AutoMapper. Maybe you love it, maybe you hate it, maybe you think it's overused. Lots of opinions. It has over like 100 million downloads on NuGet, so it's used in a bunch of places. And essentially the idea is I've got a source object, I got a destination object. I want to take the stuff from source and create a new destination type with the properties that are here. Now, there's more than you can do than just that, but I don't want to get into all the details of AutoMapper or object mapping. That's the TLDR version of what you're trying to do. Okay. Now, to do this in a way that is flexible, you have to do something that's kind of reflection based. You might optimize that with expression trees and compiling those at runtime, so you actually have IL running, blah blah blah. You know, those are somewhat advanced techniques, but that at least gives you the ability to say, I don't need to know what the source and destination, what they look like. I'll just go through reflection and find all the properties and match them all up and make that work. What if you could figure out the path? What if you could figure out what that is and generate that code so that you have something that's optimized right in your assembly? Okay, and that's what you can do with source generators. So you'll see here that I have a source class here. And this source, I have a map to attribute that says, what can I be mapped to? Again, this is just simple. There's a lot, I can have it go the other way from destination to say, what can the source be and blah, blah, blah. But for right now, I just have it. So you have to say, this is what the destination is. Okay. And so I'm saying I could be mapped to destination. I have an ID, a name, and a when property. Here's my destination, which also has the exact same properties. Okay. So I create a source here. And now I have a map to destination method. Where did that come from? It's not on the source. Is it an extension method? Well, it is, but I didn't write it. Okay. The source generator did. And so that source generator, if I have the NuGet host project as they start up and I run it, what we should see here are 3 outputs in the console window that have the exact same values as the source. Yeah, and we do. So what does map to destination do? Well, if I have 12 on it, I can jump right in the code. Now notice up at the top here, it's saying this file is auto-generated by the generator, blah, 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 and cannot be edited. Okay, so you can't edit generated code. And this is kind of like when you'd see in the past from T4, some people would have a comment up on the top that said, this was generated by a tool. And of course, some people are like, oh, I'll put that in every comment file. So it's kind of the same thing though. So this is what my source generator built. It looked at the source, it looked at the destination and said, what properties can be mapped between the two? Now, I'm going to come back to this, but let me just give you a feel for what you have to do to create a source generator. So my inline mapping project here, I have a map to generator. Okay, so this implements iSource generator, and it's also attributed with generator. And there are 2 methods on iSource generator, one that you have to implement, the other one you can if you want. The can if you want is initialize. And what I've seen mostly from initialize is people doing what I'm doing here, which is to set up what you can kind of think of as a filter. What I'm filtering for are just type definitions that have that map to attribute on it. If it doesn't, I don't care. I'm not going to do anything with it. Okay. So that's what this receiver is going to do. So I have a receiver here that's going to get a whole bunch of candidates. that when it's told to visit the syntax node, and this is where the whole compiler API infrastructure is going to kick in and say at some point, here's a syntax node, do you care about it? Well, I'm only going to care about it if it's a type declaration syntax. And in its attributes, it has something named either map2 or map2 attribute. Notice at this point, that's about as close as we can get. We can't really dive any deeper than this. But if this is what we catch, then this is the type we really want to look at. Okay, so we can filter down those types. Then when I get to the generator, up in execute, I can then look at the context syntax receiver, see if it's what I'm looking for. And I'm not going to go through all this code, but essentially what I'm going to start to look for in the receiver is, do you have any candidates? In other words, do you have any type definitions that have that attribute on them? Okay. And if it does, at some point, I'm going to call this generate mapping method that I created. And this method, if I go through the mapping builder, which is where all the good stuff happens, again, I'm not going to go through all this, but if you can kind of start squinting at what you see here, I'm going to put in a using system, and I might put in another using statement based on where the destination type is and what its namespace is. And I'm going to start putting in a public static partial class with a type name with mapped extensions at the end of it. Then I'm going to create a static map2 method where I have as its argument the source. Okay. And then I'm going to say, well, if it's not a value type, then I got to check to make sure it's not null. Otherwise, I'm going to throw an exception. But if all that holds, then I'm going to start building a new destination type. And all these maps are just saying, what are the source properties and the destination properties? And so I'm going to write equal, one is equal to the other with these maps. And that's what you see here. Okay, that's what's generated. So if I now try to do some Visual Studio stuff here, or hopefully that gets put in the right spot and Visual Studio doesn't crash on me because it's really thinking hard about what I just did, which is not good. Oh, is that even better? You know what I just did? I think. Oh no, it's still thinking. It's really hard for Visual Studio. Oh yeah, I did crash it. I just crashed Visual Studio. So that's awesome. That's just amazing. Let's try this one more time. Actually, I've never had that happen. Let's carefully put this over here. Oh, it's going to die again, isn't it? Wow, that is unexpected. I've never seen that before. You know what I can do, though, is I'm not going to attach it. I'm not going to try to dock it in some spot. Let's let it fail, and let's let it reload Visual Studio and see. Ken, you work at Microsoft, right? You can just fix this for me, correct?
Sure, yeah, I know a guy. I'll get him right on that, yeah.
Yeah, I'm sure. This is easy. Why can't you just fix this? Oh, now it's not even coming back. That's even better. All right, one more time with feeling. Except this time, we're not going to dock it. We're just going to kind of let it float. And the reason I want it to float is because I want you to see the code change as I'm editing these files. Okay. So remember, Jason, don't dock it because that's not good. So I'm going to say F12. Let's just kind of put this over here. Okay, good. Except now that I do this, well, okay, now we're going to play the, let's just align the windows like that. Okay, that's just awesome. Okay, so we'll pull this down a little bit, and I'm going to put in a property here called public string data. I don't care. Doesn't matter what it's called. Okay. Now notice nothing's happened yet in our code generation because there's no matching property. Now I'm going to copy and paste that there. Boom. Data equals self.data. So that source generator ran, generated the new code so that we actually have the correct mapping based on, we now have a fourth property that we can now assign one to the other. Okay. Now, and on the one hand, it's really cool. On the other hand, I'm going to be completely honest and say trying to build one of these things is not simple. because you need to understand how the compiler API works. You need to understand syntax trees. You need to understand semantic models. Okay. But if you're willing to spend the time to do that, you can end up generating something like this, where I now have an extension method that does a mapping for me. There's an example from Microsoft that shows that you can now auto-generate the support for iNotify property change. I've created a mocking library called Rocks that I've updated recently to use source generators. So all the mocks are created at compile time. I've heard of somebody that's creating a IOC container, version of control container. Well, all of the references are determined statically at compile time, so you have no runtime overhead with the ILC container. And another one I heard of recently is somebody went to looked at Blazor and said, I'm going to look at all the components, and I'm going to find all the routes that are defined on the components through a source generator, so I can create a type that has listed all of the possible routes that you can go to in this application. I thought that was really unique and that was really cool. So source generators are awesome. I highly, highly recommend taking a look at these, because the work that's being done on these things is just, there's so much community work being done there. Okay. Looks like Jason needs one of the JustGreen licenses. Yeah, that's fine. I have to admit, I'm Team Visual Studio. I really like Visual Studio, but it's Rider's fine too. That honestly, I've done this demo where I've docked it like that, and it's never been a problem. This is the first one. So believe you me, if I can repeat that and capture that, I will try to get that into Visual Studio. And Ken can take a screenshot of that or video and send it into the people on the Visual Studio team and say, wow, that looked horrible. That should work. So let me see here, just the questions here. Is record ideal for POCOs with lots of properties? Sure, I think so. I personally wouldn't see a problem with that at all. You don't have to use that kind of constructor syntax either that I showed. You can define all the properties yourself if you want. That's perfectly fine. So you don't have to be limited that way. But yeah, if you've got 20 properties, if you really have that big of a POCO, then you can do that. Regarding VAR, I agree on customer, but what is your opinion on that? I like that. I'm okay with that. Some people don't like that because it's if I'm reading it in GitHub, I can't tell what the type of that is, but I'm fine with that because mostly I'm looking, well, a fair amount I'm looking at code in Visual Studio or some other editor where I'm going to be able to figure out what that is. There is somewhat of a valid statement to say if you just want to read the code through like a text editor or something, then it's a little harder to kind of see what that is. I would guess that is by the names of everything, it's a person response or a facilitator response. So I'm okay with that. Can also do X as object and say, yeah, that's true. Yes, you can. What's the use case of source generators? I hope I just answered that. Essentially, well, let me restate kind of what I've all did. Source generators, all it is a way for you to generate new code. That's it. There's nothing really that special about it other than you can add more code to your project. What you're probably going to use it for is to optimize cases like when you're doing the object mapping. For example, I did a quick performance test here where I compared taking what I did with my inline mapping with doing a reflection approach and comparing all that to AutoMapper. And again, this is don't take this as AutoMapper sucks, because that's not what I'm trying to get across here. But with all these doing the same thing, my inline code is faster than all of them, and it allocates the least amount of memory. Okay, but that shouldn't be surprising because there's no reflection involved at runtime. It knows the optimized path, and that's what's being compiled into your assembly. So there really is no faster way to do it, arguably. So that if you got a lot of reflection code that's trying to do things generalistic in your application, source generators may be a really cool way to optimize those paths and just not have reflection be a part of your code. That's another option. And again, like the mocking example, which I didn't show, but one of the cool things with that is I'm able to build a whole API for the mocking to make it much easier to state your expectations, and I have a lot more flexibility that way as well. So that's kind of the short answer to why they're what's the use case of them. Do uninitialized types represent a security risk? Possibly. What they actually probably have as more of a security risk is that if you'd accidentally use a non-zeroed out variable, that it might have data in there that potentially will act in a way you didn't expect. So that's the shortfall of it. But if you're going to try to get optimization from that skip locals init, is because you're doing a lot of lower level stuff anyway. So hopefully you're doing the right thing in the first place. Okay. 2 years from now, the junior maintenance programmer comes across this and quietly starts sobbing. Yes, yes and no. If you're talking about source generators, I think that's what you're getting at, Elton, is it's not simple. I will admit it's not simple stuff, but it's if you're willing to pay the cost of writing a source generator, the end result is, the benefits of all those things I talked about before. How do you debug a source generator? Very, very easy. So if I go back into my program method, my program class here, am I in, whoops, no, not that. Am I in debug? No, now let's go into debug. I got a breakpoint there. Let's hit F5. And once it's done building the debug version of this, and we launch into the debugger, come on, you can do it. This is a fast computer, it's just slow. Okay, so I'm at this line. If I F11, I step right. That's the advantage of this over some other tools that may do like IL weaving and whatnot. And to be clear, source generators don't let you change code. You can only add code. So there is no weaving of code or aspect-oriented programming or anything like that with source generators. Okay, but I can add the code just like C#. It's compiled directly into the assembly. So everything with debugging just works. So I can come into here, I can see what self is, I can see what the values are. Nothing's a surprise at all. So very easy to debug source generators from a debugger. Now, if you want to unit test them, that's a little bit of a harder discussion, but I'm going to skip that right now because I want to keep moving. If you don't like var everywhere, consider the option for one variable. Yep, you can do that. All right, I think I got to the end. So let me finish up, and I can answer other questions if I inadvertently skip them. All right, so where do we go from here? Using the crystal ball, so to speak, to look into the future is not needed anymore because everything's out in the open. All the design work, all the bug fixing, everything is out there. In fact, it's almost overwhelming. If you really dive very deeply into the C# Lang repo, there's a whole bunch of stuff out there. So there's no surprises, so to speak. This is, if you go to the link here, this is what they call C# Next. Doesn't have a version. There's no guarantee as to if these things will be in the next one, or if more, or if less will be there, and when it's going to happen. But this is kind of what they're looking at for whatever that future version may be. And again, this C#, if it's C# 10, it may not tie to C# 6. They may not do a version update this year. Maybe they do a 9.1. I don't know. I haven't seen anything other than if somebody knows that they've seen something, that'd be cool. But what I have seen with C# Next are these features. And I just updated this right before we started because I noticed they added a couple since the last time I did the slides. They are looking at, can you define records using structs? So can they have some type of syntax to say, I want a struct-based record rather than a class-based one? Name a parameter. So if you have an attribute for a method where you want to specify a specific parameter, you've never been able to do that other than using some string weird, hopefully the name of the parameter doesn't change. They want it so that it actually now works with the name of parameter. So that's kind of cool. I want generic attributes. You can actually do those in IL and consume those in C#, but you can't build them in C#. So I'm hoping they actually do add in generic attributes. If you're interested in diving into what they're looking at as things in the future, like working set or some things they've considered that are on the backlog, you can go to this site. You'll see this thing at the top here, type classes, concepts, structural, generic constraints, blah, blah, blah. I don't know if this will be in the next version. This is something they've talked about a lot. It's been out there for a while, and I hope at some point they actually do this, because this would, I keep using the word expressivity, but it is a perfect definition or description of this feature. It would make the type system so much more expressive, so much easier to work, and so much more powerful. If you've used languages like TypeScript, where you have structural typing rather than nominal typing, you know what I mean, that I don't have to have something derived from something else, so I can pass it into that thing. As long as it would structurally match, I should be able to pass it in. And I can't do that in C# right now. But this feature would actually do even more than just that. So hopefully they can eventually get that in there, because I think there's a lot of benefit to that one. There's this site too that also talks about feature requests that people have made and discussed and proposed. If you actually want to build a feature in C#, it's possible, but it's not easy, okay? To actually build a feature takes a lot of work. So understand that the time investment is not going to be minimal. It's going to require some effort on your end. And they do have this document out here that talks about how you develop that language feature. But it's been done. The community can light that fire to actually get features built into C#. One of them was in C# there's something called expression body methods. Okay, where you sometimes use the arrow syntax if you only have like one statement in your method. That's fine. That will work. But that wasn't done for constructors and properties and other things. And the community said, hey, we want to put that in expression bodied everywhere. And that's what happened. So it's possible. It's possible that people can actually do that. So I'm done with my presentation. I hope that you've enjoyed it. I hope that you got a couple things out of it. And if you haven't dived into C# 9 just yet, there are a lot of cool features there. So hopefully this will help you when you actually have to get into it. Or if you've already been into it, maybe there's a couple things that I showed that you didn't know just yet. Either way, hope you enjoyed it.